Hey Finxters, what's up? It's Chris, founder of Finxter.com, and in today's video you're going to learn the Python format function. And this is meant to be a no BS guide by example. And so actually I have searched this topic, Python format function, so the built-in format function, and I have only found, sorry about that, but I have only found shitty tutorials that are really they don't motivate why we should use the format function. They don't like show you step by step how does it work, what is the format specification language, and so on. So where it is used, why you should care, and like the how does it work step by step the function. And so I've created this guide on the Finxter blog, and you can check it out. I give a link in the description below, but I would just go over this guide to just make this guide even more helpful, explaining it in video format. So let's dive right into it. So what is the format function and why should you care? So if you're a data scientist, you know that data cleaning is everything. So it's not everything, but it's a big part of the equation. So you need to have big data in a specific format in order to train your models, in order to visualize the data, and actually processing the data. And even like on a more higher level, as a programmer, you write programs that transform data from one input to another into another output. Okay, so we have the transformation from input to output. This is a function. Yeah, this is everything a function does, and this is in the end it's everything a program does. You put in some input, the program does the processing, and you get out some output. So everything that makes you more effective in transforming data from one format to the other will make you a better coder. And there are many different ways like to approach this. For example, learning about regular expressions is perfectly so one of the most effective things you can do as a programmer. But then as a Python coder, if you are like intermediate level Python coder, you must start to think about how to use the powerful string formatting functionality in Python, because it is just so much more concise, much more effective way to process data, to get the data into your custom output format. Okay, so for example, if you have some data in this format, like 911, so maybe let's open a code share, clean one. Okay, so for example, if you have some data like this, say 11/09/2020, something like this. Maybe you want to transform this into another data like this one. Yeah, so you want to get rid, for example, of 10 in the month part. Or maybe another example is if you have like the data like this. So you have say some house prices, and they give the house prices like this. So we have like a number with commas and then a dollar sign, and maybe you want to transform this data into the other format where you don't have any commas, because you need to process it without the commas, for example, and with the leading dollar sign, yeah, something like this. So maybe you want to do these transformative quick tasks, and these are it's very frequently you have these kind of tasks you want to apply to your data, and the format function, just like this, the format function is a Python built-in function. You don't need to import it, and this can help you do all those small little processing tasks. So let's dive into the format function with the definition. So the Python's built-in format function takes two arguments: the value. So it takes two arguments, value and the format specifier, yeah, like this. So these are the two arguments of the format function, and it transforms this value argument into a new representation as defined by your formatting specification string. Okay, so both are both. So this can be, for example, an integer value 42, and then you have some magic format. I just call it magic. Some formatting string here, and this one tells you how to format this number, this value that you pass as a first argument. Okay, so the second argument is kind of the command that changes the first argument, changes the format of the first argument. So for example, the basic example I always use is to format an integer into a float. So for example, if you have if you have this one, yeah, so you have you pass an integer value, you pass a float formatting string, so very simple formatting it's a very simple formatting string specifier, sorry, formatting specifier, and then you transform it into a string value that looks like a float value, okay, with a floating point number. So this is not a float value. You can see there are these quotes around the string. So this is not similar to float of 42, like, because float of 42 will just create a float type, but the format function, when applied to the integer 42 using the format specifier f, will simply create a float representation of the integer input. This is like one example, one of many different examples you can use as a formatting specifier, as you will see in a moment. But maybe let's start with the simplest example. If you just pass a number like 42 without any formatting specifier, it is the same as using an empty formatting specifier, and this will just then create a string representation of the data. Okay, you can already see, like, the inside number 1, the output of the format function is always a string value. Yeah, we have seen this in this example. This is string value, and in this example, this is string value. So the output of the format function is always a string value. And the first argument is the value to be formatted, and the second argument is the format specifier. I call it format specifier. And okay, so what can you do apart from like format something into a float? So say we have again this example, format 42 into a float. And now you see it has like 6 trailing zeros after the decimal point, which may not be what you want actually. Maybe you want to have only 4. How can you do this? Yeah, fortunately the format specifier allows to add an .pf. So I will explain in a moment. So we still have our type format specifier. The type is f is float, so we want to convert it into a float. So the type is always the last character in the format specifier. But then we also have this part, yeah, this .p, and p is now the precision we want to have. So for example, if we convert into a float, as I said, we can also convert into other data types. But now just stick with me for, like, by example, we will go over different options you have. Okay, if you want to So if you want to convert from an integer to a float, you can define a certain precision, like .p, and p is an integer number. So for example, we can have 4 zeros, yeah, after the dot. So this is .4 to have 4 zeros. So what if we want to have, say, 100 zeros, then we simply write 100 here after the dot. Okay, then we have a 42 with many zeros. So this way you can define the output as you want. Okay, so let's have another example, like a canonical form or standard form of floats is often with 2 decimal points, something like this. Okay, so this would be, for example, this could be a dollar amount, because there are no smaller fractions of a dollar amount. Okay, so dollar amount you would write with only 2 positions after the decimal point. Okay, so this way you can take a number and format the number according to your needs. And this is the format specifier, is one way of doing it, using the .p prefix. So with this dot prefix, you indicate that you want to now define now next comes the precision, and you define the precision as an integer number, and then you add the type of this. Actually, speaking of which, what different types are there? So for example, can we also convert into other types? Yes, we can. So we can, for example, have format 42 and convert into a binary number using the b format specifier, and now you see it's a binary number. So very powerful. You see, you don't have to remember all the conversion functions or so to convert from one format into the other. You can simply use this one. In many cases, it's totally valid. So we have 10 10 10. This is a binary representation of 42. Yeah, so we have 0 times 1 plus 1 times 2 plus 0 times 4 plus 1 times 8 plus 0 times 16 plus 1 times 32. Okay, we have 32 plus 8 is 40 plus 2 is 42. So this is like the binary number of the decimal number 42. Then of course we can also have like the reverse. We can, for example, input a binary number, prefixed 0b, and let's simply put in the binary number for 42, and now we use the format specifier d for a decimal value. Then it converts it into a decimal number 42. Okay, as a string, not as a number. So you cannot like use the output of the format to, for example, add it to another value. So for example, if you would do something like this, so you add together both, then of course you would obtain a string concatenation, not an integer addition as you would expect here. Yeah, because the output of format is always a string, as you have learned in this video already. Okay, so I think these are the most important ones. Maybe I will show you one more. This is the exponent specifier. So we can have format. So for example, say we have the number 1000. Now we can use the exponent specifier with the precision as well. So now the precision doesn't apply to the float value; it applies to the multiplier of the exponent. So you can see it here. Now you see it's the precision of this multiplier, and we have this representation. So we have 10 to the power of 3 with this exponent functions. Okay, so we have 1.00 times 10 to the power of 3. This is how you can read it. This is like a scientific representation of large numbers. So for example, you can now have a number with many zeros like this, and say we don't want to have any, we just want to have a rough format. Okay, so then we, like here, we don't have any positions after the colon, yeah, because we use the 0.0 precision. So we have 1 times 10 to the power of 14 because we have 14 zeros. Okay, so this way, very powerful. You can transform these type of numbers into these types of outputs. I think these are the most important specifiers: the B for binary, D for decimal, E for exponent. And there are many more. You can also check them out in the tutorial. But I think just to get a rough idea, how does it work and how does it very costly, how does it work? So I will just go over the different things you can do, and then you can check it out yourself. Oftentimes I have to Google myself if I use the formatting string. I don't know this or that thing, then I just Google it quickly. But I think the fact that I know that it is there has helped me already a lot, like in my coding productivity. So I think it will be useful for you too. Okay, another format specifier is the width specifier. Okay, so say for example we want to have like this. In this case, the output string has 4 characters, so the width is 4 characters. Here it is 2 characters only. So what if you want to define a specific width for our output? Yeah, we can do this with the format function. As I said, it's very powerful. We can, for example, do the following, like say 25f. So we convert 42 into a float using this float type in the end as a suffix, but then we also have simply a number. So if you give the number without the dot, if you give the dot, then it's like the precision format specifier. But if you don't give a dot, it's just a number of digits. Yeah. And now the number of digits is like 25. You can see it if you have the same 42, but then only with say 15f. We have a shorter string, okay? So the string is shorter now. So this way you can ensure that, for example, all string outputs of your program have the same width. And so, for example, if you use a table or so and you want to like fill in 1 character per column or so, then you need to ensure that they all have the same width, no matter how the addition maybe work out. Okay, so maybe this 42 is happened because of an addition or a computation, and it could be 42, it could be 4216.7778, and now you would have, like, if you have different numbers, they would have a different width in your Python shell. So the string representations of those numbers have a different width, but you can fix this simply by using this width format specifier as a prefix. Okay, so this is also one powerful way of doing it. And the nice thing is that you can combine different specifiers. So for example, you can combine this width specifier, which comes first, with the precision specifier. Yeah, now this part is the width specifier. This one is the precision specifier. How many digits after the colon do we use? After the decimal point? Yeah, correct. It's 2 digits, and we also have the float type specifier. So this format specifier consists of 3 a combination of 3 format specifiers. The first one for the width, the second one for the precision, the third one for the type. So, and if you run this, we get this beautiful representation. Okay, and so, for example, what would be an application of this? Let's close this shell maybe and copy some code. So say we have this code, yeah, this is our code we have. We have a list of float numbers, and you see they have different precisions. And if you print them, so let's print them to the shell. So we go over all floats and we print them to the shell. We obtain this output, which doesn't look very pretty. Yeah, I mean, they have different number of positions after the decimal point. They have different number of positions before the decimal point, and they are not well aligned, and it doesn't really look beautiful. So how can we fix this? Simply by using the float format specifier. So we pass f, which is our float number, into the specifier, and now we simply define it. Yeah, so for example 15.2 for the position, and then we convert into a float and we close everything. So this one would now have a result in like 15 positions with only 2 positions after the decimal point and converting it into a float value. Okay, and if we run this code, we see now they are nicely aligned because all of them have the same number of positions after the decimal point, and all of them have the same width. So therefore we align them beautifully, and you can immediately see like the biggest number, for example. Yeah. So this one wouldn't necessarily, the number that has the most digits wouldn't necessarily be the biggest number, because it could also have all those digits after the decimal point. But in this case, if we cut it if all of them have the same number of digits after the decimal point, then the number with the most digits actually is also the largest number. Yeah, so this way, for example, it's easier to see it, the output is prettier. And yeah, so this is what you can do. You can and so in a more general note, there's a format specification language, and it looks like this. So you start with a format specification. This is the part we put here as a second argument, yeah. And you can, so what can we actually specify? Yeah, and there are a lot of things actually. All of those things you can replace it with. And you can see now everything within this bracket is an optional argument. Okay, so we can, for example, have you have already learned about this type specifier, which was the f in our example for converting it into a float. This is always in the end, it's always the suffix of our format specifier. But then we can also have precision. You have seen this, precision. Then we have grouping option. We have the width. The width you have already seen as well. It's all of those are optional actually. Yeah, so you can use them or you can't use them. It's like it's your choice. You can have a sign, and you can have an alignment, and so on. Yeah, and now if you take one of those, so say you decide, so I've given an example here. Say you decided to have to replace it with fill, align, width, and type. So we have you use this one, this one, this one, this one, and this one, and now you need to check. Okay, fill. But how can I replace fill? Yeah, fill can be replaced with any character. So you simply put any character here. Align can be replaced with one of those characters. Width can be replaced with digit, an arbitrary number of digits. This is this plus operation, plus quantifier. So it has one or more occurrences of the preceding expression, and the preceding expression is simply one digit. So from 0 to 9. So we can have an arbitrary number of zeros or nines put together, and then we have, like, this is our width. Yeah, and precision also. Yeah, so and let's have maybe an example. So this one would be an example. We use the format built-in function on 42 using x as the fill. So we replace this fill part with any character, so for example with x, and this simply fills all the remaining positions. Per default it's an empty space. So you have seen this before. For example, here we have filled, so if you have a width that is larger than the string representation of the value provided here as the first argument. If it is larger, then you simply replace with empty spaces per default. But if you can also define a fill character as the first prefix, and it's also optional, but we can do it, the fill character, and then we have an equal symbol for the alignment. So what does it mean, alignment? Yeah, for example, here in this case, we align all of them in the center. So this equal symbol is align at the center. We could also like have this number. We could align them on the right or on the left of our thing. So I will show you an example maybe in a moment. So if you run this, you see, okay, let's make it more positions so that it's actually, oh no, I think it's fine. So let's add an format specifier, .2, the precision specifier. So now you see we have a smaller precision actually with only 2 digits after the decimal point. And now this is 42.00, and this is right aligned per default. Yeah. So and we fill the remaining stuff, the remaining positions of those 15 positions we require. We fill it with some X's. Okay, but we can also, like, for example, use this one. Now I have not tried this. Now you can see it's left aligned. Okay, so this 42, it's now aligned on the left instead of on the right. Okay, so this way you can control the alignment where the fill positions actually come into play. Okay, so this way you can arbitrarily place your value, which is this 42, into like an environment, actually, an environment of characters, and you can define those characters here. Okay, so I think these are the most important things you need to know, like conceptually, how does it work? You can always, if you have the challenge to, you have one value, one number or another, or a string or so, and you want to actually format the string, you want to create a new variant of this string with a different format, then check out the format function and simply know that there is something. You can Google it then, and you can check out these different specifiers. You have now learned how it actually works. It works with this very simple language. Yeah, the language is very simple. It consists only of like 10 rules, and you can check them out quickly. You need to study them once, say for 5 minutes. Just stare on them for 5 minutes and try to make some sense out of them. It reads itself. Actually, if you know that this square bracket notation is an optionality syntax, so we have like this whole part is optional. But if you add, for example, if you want to add the fill argument, the fill expression, you also need to add the align expression, yeah, because the fill expression is placed within the align expression. Okay, and then we have the sign expression, which is optional, and so you can quickly figure out the different meanings of those. But like using the language and understanding the concepts, this was the idea of this whole video, and I hope that you now understand the format specification language better, and you know how to apply it to the format function in order to convert your own strings into different formats of the same, or values in more general, to different formats of the same value. Okay, thanks for listening to this video, and see you in the next video. Bye.